how do the past's greatest buildings measure up in the 21st century? In this series, we're going to use the most advanced technology on the planet to put history's building wonders to the test. Famous structures around the world, pored over for centuries by archaeologists and historians. We've never truly been able to uncover all of their secrets. But now, scientific breakthroughs have created an amazing new laser technology that can capture and explore these structures in a way no human eye can. For the first time, allowing us to understand some of the oldest mysteries of the engineering world. This time, the time scanners are heading to Egypt to discover how the most famous structures of the ancient world were built, the pyramids. We're using our laser technology to uncover secrets thousands of years old.
There isn't an engineer on the planet who wouldn't love to be in my shoes today.
We'll see how the skills of the ancient pyramid builders evolved radically over a century.
It really does boggle the mind.
We're going to peel back the skin of these iconic structures.
This is where the magic happens.
Using this new technology to make discoveries that will change the way archaeologists think about the pyramids.
You open a new page. Well, I have to change some pages of my PhD, you know.
We're going to shed brand new light on the pyramids of ancient Egypt. Egypt. Home to one of the most mysterious civilizations ever. Born on the banks of the River Nile 5,000 years ago. For thousands of years, Egypt was one of the greatest nations in the world, ruled by the mighty pharaohs. In life, these all-powerful leaders demanded extraordinary devotion from their people. And in death, they demanded awe-inspiring structures to be built as their tombs. They're constructed in many different shapes and sizes, built on a scale never before seen on the planet, honed over a century of engineering failures and breakthroughs. And now, thousands of years later, stand as a tribute to the skills of these ancient builders. And king of them all, the Great Pyramid at Giza. Fascinating experts and bewitching tourists in their droves. At nearly 150 meters high, the Great Pyramid was the tallest man-made structure on the planet for nearly 4,000 years. The pinnacle of pyramid engineering, with a vast burial chamber hidden inside. But only 100 years earlier, the Egyptians were building their tombs with simple mud bricks. So how did the ancient engineers arrive at the Great Pyramid within just a century? There is no doubt when you talk about the pyramids, you automatically think of this one, the Great Pyramid here at Giza. And just being beneath it does fill you with a sense of wonder and awe. It is the ultimate in ancient engineering. With our technology, we're able to follow this remarkable story of pyramid engineering evolution in a whole new way. Recent scientific breakthroughs mean we now have a device portable enough to travel the world and access these incredible places, and powerful enough to explore deep inside their structural secrets. The mobile laser scanner. These bounce narrow pulses of light off objects to map them with incredible accuracy. What's packed into this tiny box gives our experts virtual superpowers, collecting over 1 billion measurements to form what is known as a point cloud, giving us an incredible 3D perspective, the ability to pick up million-ton structures and move them anywhere, and use this data to take precise measurements with pinpoint accuracy, to peel back time and help us unravel mysteries locked in the past. But the real key to the technology is in the interpretation of this data. And we're seeing it through the eyes of one of the world's best structural engineers, Steve Burrows. A master of the modern building world, Steve has created such famous structures as Beijing's Bird's Nest Stadium, Munich's Allianz Arena, and Manchester's Etihad Stadium. Steve has always wanted to explore the great engineering mysteries of the pyramids, and now he's got the technology to do it. People have been wondering how they were built for thousands of years, and we've got to come along and give some new answers.
We set ourselves a pretty big task, right?
Armed with this scanning technology, structural engineer Steve wants to understand how the ancient engineers honed their skills to arrive at the peak of pyramid building, with the Great Pyramid here at Giza in just 100 years. To do this, he wants to examine 3 earlier pyramids, which he thinks hold clues to this engineering revolution. Starting with the Step Pyramid, the very first the Egyptians built, followed by the mysterious Collapsed Pyramid, and finally investigating the unusual shape of the Bent Pyramid. To aid this mission, Steve has brought a team from one of the world's best research centres, Caitlin Stevens and Malcolm Williamson from the Centre for Advanced Spatial Technologies at the University of Arkansas. The team's quest starts 27 kilometres south of the capital, Cairo, at the Step Pyramid at Saqqara, in the desert to the west of the Nile. It's the world's first pyramid and the oldest large stone building on the planet, containing 6 stepped levels and a rabbit's warren of subterranean tunnels and chambers. It was built around 2630 BC by Pharaoh Djoser. If we're going to discover the engineering process behind building a pyramid, this is the place to start. The Step Pyramid isn't as famous as the pyramids of Giza, but Steve assures me that actually it holds the key to understanding the genius of Egyptian engineering.
Here we are at the oldest skyscraper on the planet. What do you think?
Not bad.
There's a lot of scaffolding.
Let's not focus on the restoration. I want to get under the skin of it, so let's not just scan the outside. Let's try and scan as much into the depth as we possibly can.
Steve sets the scanning team to work. The data will allow Steve to better understand what the pharaohs were thinking when they first came up with the radical idea of building a pyramid.
It feels like being at the birth of engineering, because I know they actually designed this. It wasn't just piling some stones on top of each other and crossing their fingers. They actually planned it, and look, it stood the test of time.
Building pyramids was a monumental challenge. It required vast amounts of rock and earth, thousands of people, cutting-edge engineering, and groundbreaking ambition. To better understand the people that gave birth to such incredible creations, I've come to meet Egyptologist Chris Naunton. We had this coming together of people, skills, of ideas. How do you get from that to building these extraordinary monuments?
I think it's testimony to how hierarchical and stratified the society is. So you've got one guy at the top who's supremely important, and an entire country's worth of people who are prepared to believe in that one person and that one project, and to hold that belief for the number of years it takes to build a pyramid.
Each pyramid is a royal tomb with secret passages leading to a burial chamber, the final resting place for the pharaoh's mummified corpse. Believing in an afterlife, the pharaohs were buried with precious objects, including golden statues, gilded furniture, and incredible death masks. But the pyramids were much more than just royal tombs. They were huge temple complexes, and whole new towns formed around them, creating industry and wealth. The first pyramid the Egyptians ever built was the Step Pyramid at Saqqara. Well, let's talk about the Step Pyramids. Is that the first proper high-rise building?
It's the first monumental construction in stone anywhere. If anything mankind had achieved up to that point looked like the work of God, it would have been the Step Pyramid.
Back at the pyramid, the team have been scanning hard, and the data has started to come in. This is our Tech HQ. Here we can collect all the data taken from the scanners to form 3D models for Steve to analyse. The individual scans have been digitally joined together to form a point cloud.
This is just the computer giving us this image. We didn't fly over it or anything to take this picture. This is clever data point
Data
manipulation.
collected from all four sides, put together and then viewed from above.
Steve can move around the point cloud in any direction he likes, giving him a vast amount of data at his fingertips. Looking at it, he's noticed something about the step pyramid's construction.
See this here, like this point here? We can actually see that there was a mastaba first.
Steve has seen the evidence of this pyramid's simple origins in a structure called a mastaba. The Egyptians had a history of burying their dead in the ground. But the wealthy and powerful constructed mastabas, structures made of mud brick. These single-story shrines, visible above ground, gave people a place to bring offerings. However, when it came to the pharaoh Djoser, he decided to break the mold. Because of his unprecedented power and wealth, instead of using simple mud bricks, he chose to build his mastaba from stone. For him, a single story just wasn't grand enough, so he ordered it to be built upwards. But this was not an easy engineering challenge.
They were aware that the extra weight was going to put more pressure on the ground. They definitely knew something about the idea of overloading the ground. And as they went and built levels on top, they actually built the mastaba bigger sideways.
Steve thinks that to support the vast weight of the pharaoh's ambitious structure, the architect had to employ a stepping system, extending the single story out sideways to create an even larger footprint and support an even greater height, giving Steve the first clue to the evolution of the pyramid's shape.
This structure really represents the beginnings of pyramid design, that evolutionary journey.
Yeah, it's the first time that you really see that shape emerging, that sort of pyramid idea that we know so well. If the pharaoh asked me to put 5 extra layers on top of an existing mastaba, the first thing I'd do is run a mile. The idea of piling on this massive weight, you know, it's a very risky proposition. But once the shock had passed, I'd definitely start building the building out, making it bigger, to spread the weight out on the foundation, and I can see that they did that.
But for all the towering magnificence of the outer pyramid structure, it's within that some of the most amazing architecture can be seen. And the laser technology can be taken deep inside the maze of tunnels leading to the burial chamber of the pharaoh himself. We are unlocking the building secrets behind the mighty pyramids, tracking their evolution through a century of design innovation. In the Great Pyramid at Giza, the peak of Egyptian engineering, the pharaoh's burial chamber sits inside the heart of this enormous structure. The huge space of the tomb is able to withstand the weight of millions of tons above without being crushed, a very difficult engineering task. So almost a century earlier, what did the burial chamber in the very first pyramid look like? Steve heads to Tech HQ to examine the scans.
Everybody sees the step pyramid from here and above, and what we've been able to do is to actually look at it from below.
Presumably it's a lot easier to build below ground than it is within the heart of the pyramid.
But if you do it below ground, it's like a cave. The actual rock does the job for you. At this point, they had no means of carrying tension, and therefore they knew that they could only create big open spaces right down in the earth.
To prevent the burial chamber from being crushed by the weight of the massive pyramid above, the ancient engineers used their structural knowledge to tunnel deep underneath the pyramid. This way, they could use the natural strength of the bedrock for support to maintain the open space of the chamber.
We can understand how the Egyptians managed to build so high, but we're still quite a long way off from the classic pyramid shape. So how did those Egyptian engineers refine their technique to create the pyramids that we know so well?
To find the next link in the evolution of the pyramid chain, the team is travelling to Meidum, 80 kilometres south of Cairo. to one of the most mysterious pyramids ever built, known as the Collapse Pyramid, and very different from anything that came before. Construction began around 2575 BC. Built by the warrior pharaoh Snefru, Steve thinks that this structure could hold a vital key to understanding how the Egyptians mastered building big.
Hopefully this pyramid is going to offer some clues on how you get from a stepped pyramid to the classic, iconic pyramid shape. And if you're wondering how, it's because 4,500 years ago, that looked a lot different.
Experts believe that the Collapse Pyramid was once built as a step pyramid, which was then covered in an outer casing that gave it flat sides, the first time the Egyptians had achieved the well-known pyramid shape, and a huge leap forward in their design and engineering ability. But unfortunately, it ended in disaster.
It was a step pyramid. They put a true pyramid over the top, and that started cracking. And it would have cracked at every step line all the way around the outside.
But why did the pyramid's outer casing give way? For the first time ever, we're going to use laser scanning on this ancient structure to try and find out.
My first thought, there's a bigger pyramid that's fallen off that really steep inner casing. And so I'm sort of interested in why that's happened. What is the connection between that very steep sheer face and all this collapsed section at the bottom? So I want to get some detail on those collapsed areas.
The scan team gets to work. Malcolm is scanning from a distance with his powerful long-range scanner to understand the larger structural story. And Caitlin is working closer in to see if there are micro details in the stones, only visible to the laser scanners that could hold clues. In Tech HQ, the laser imaging of this 4,500-year-old pyramid is starting to come to life.
Was that not designed to be seen, that structure, as it is?
Yeah, this was phase one, if you like, of a two-phase development. So what we're seeing is the pyramid that's on the floor that's collapsed is phase two. They had to figure out, how do you put a perfect pyramid over an existing central core?
The laser scans are allowing Steve to unlock the engineering process used to make this structure. And from this data, he can now see where the ancient Egyptians made some critical errors.
So Malcolm, could we zoom in on this band here, just one of those elevations? So they tried to solve that problem by doing this. So what we're going to see in this central section here, see these stones?
Yeah.
This is the sort of shear key band. They put in a shear key to connect the new pyramid to the old one. And the idea was that that would stop the new pyramid sliding off the central core.
The lasers have clearly marked what Steve believes is a shear key, a band of bricks created for the outer material to stick to. But this technique didn't keep the outer casing of the pyramid attached to the inner core. Part of the base of the collapsed pyramid still exists, so by fitting two blue planes against it on two sides, Steve can start to understand what happened.
What you can see is it just intersects the corners. So that says to me they were trying to build incredibly close to the central core. So we're going to have a look down the side and have a look at the gap between the two.
So this would all have been material filling this gap here?
Yeah, laid in layers and built up right from down here, right up to the top. And the big problem here is that shear key that sits about there.
Seeing the space between the outer wall and the inner core, Steve thinks that the shear key band was too minimal to bind all that material together.
The material below tries to settle, and the material above sort of hangs off this ledge, and a big crack would open here. And basically, that's the start of the failure of the pyramid.
The scans have revealed to Steve that because the outer material couldn't bond properly to the core, cracks would have appeared. And once this happens for a pyramid, it's terminal. The enormous weight of the outer walls would have crashed down to the ground, leaving the heaped rubble that still surrounds the structure today. The Egyptians' first attempt to form a flat side of a true pyramid failed. But what about the pharaoh's burial chamber within? This part of the structure was the key for the ancient Egyptians. Steve is fascinated to find out how far their engineering had evolved when building this sacred chamber. At the Step Pyramid, the first ever pyramid, we found the burial chamber lay deep down underground for structural stability. But here at the collapsed pyramid, Steve wants to see if the ancient Egyptians were able to move the burial chamber upwards, closer to the pyramid's core. Steve is getting Caitlin to scan the burial chamber. And while she does, he's getting a better look at the construction. Immediately, he can see there are significant advances in its design.
What we can see is they understood how to make large open spaces with this technique which is called corbelling. Probably 2/3 of that stone is actually back into the wall and about 1/3 overlaps, and that enables them, by stepping in at each level, to create these big volumes.
Corbelling is a method of distributing enormous weight around an enclosed space by stepping the rocks. It meant that the ancient engineers could control the vast forces at play when building open spaces under extremely heavy weight. Steve suspects this engineering technique meant they could now build rooms within the pyramid itself rather than in the bedrock. And with the data ready, Steve can get a unique view on the scans.
If we put the burial chamber on there now, right, this is the sort of sand desert level. It looks to me like the burial chamber is built very close to natural rock level.
The pyramid base is hidden beneath a layer of sand, and our scans are showing Steve that the burial chamber is in fact encased within the pyramid structure. A huge leap forward in Egyptian engineering.
The weight of this pyramid is a mass that's trying to crush this to the ground. And what happens is that that load spreads around the outside because of this corbelling and doesn't crush the roof, but goes down to the earth below.
The pyramid at Meidum was a landmark in pyramid engineering. For the first time in history, a pharaoh could be buried within the body of the pyramid.
They've actually started to think about, how do we get this up into the heart of the pyramid? I can see the process of learning.
Our scans have revealed that the Egyptian engineers were beginning to master the control of such vast structural weight. Experimenting with the true pyramid shape and learning how to build burial chambers inside the pyramid. But before they could arrive at the iconic shape of the Great Pyramid at Giza, there was one more crucial lesson to learn. 40 kilometers away in Darshur is a very special structure. It's known as the Bent Pyramid, because about halfway up, the angle of its inclination changes from 54 degrees to the shallower angle of 43, giving it a bent appearance. Constructed around 2560 BC, like the collapsed pyramid, this one was also built by the pharaoh Snefru. With a height of over 100 meters and a polished outer casing still largely intact, it was the biggest pyramid ever made, and represents a significant change in pyramid design.
It's got to be up there as one of the most unusual ancient structures on the planet. But why on earth did they build it that shape? Well, that's exactly what Steve and the team want to find out.
There are two main theories as to why the Bent Pyramid looks the way it does. Some believe that it was actually designed to look like this. However, most believe that it was a design failure.
So if you built this pyramid and I'm the pharaoh, and I'm looking at it and going, well, I like it, but it's a bit of a funny shape. I wasn't quite what I had in mind.
I think it's pretty badly built. I wouldn't be very proud of this.
Steve wants to find out if the bent shape was an aesthetic choice or if something went wrong during its construction. And he's hoping the laser scanning can give him the answer. The team is scanning the intriguing Bent Pyramid in Darshur. This revered structure has never been analysed in this way, and Steve is hoping the new technology will give him a brand new perspective.
What I'm mostly interested in is trying to get sort of crack patterns. See if we get something that sort of gives us a clue as to why things have started to fall down.
As Malcolm and Caitlin get to work gathering the scans, Steve wants to get underneath the pyramid's skin.
For an engineer, this is a sort of dream. I feel like I'm right into the veins of the pyramid and I can understand how the whole thing sort of works and was put together. And I'm not very impressed, to be honest.
Steve can see that the stones are all different sizes. They're roughly cut, they've got uneven edges and gaping wide joints. He believes the random stone pattern is a clue as to why the pyramid is bent.
Here's what I think happened. As they got to 200 feet and maybe 250 feet, this massive weight started to move. So a bit like an earthquake, everybody's looking at this mountain of rock, thinking the whole thing's going to come tumbling down. And I think if that was the point at which this became the bent pyramid.
To save the pyramid, Steve thinks the builders made a decision to finish it off as quickly as possible, and so they topped it off with a smaller load.
They decided to put as shallow a slope as they thought they reasonably could, just to get the job finished, and hence the bent pyramid.
To find out if he's right, Steve turns to the laser scans, hoping that TechHQ can reveal whether the pyramid was deliberately bent, or whether the Egyptians were forced into changing the pyramid's shape for stability.
What is the story? Did it happen by mistake? Was there a structural problem? By design, did it look like that? It's certainly interesting, isn't it?
Yeah, and I've come along with that preconception, the idea that, you know, for the shape to have changed, something went wrong about here, and they actually tried to finish it off quickly. The idea that the center of the pyramid sort of collapsed and the ground gave way and effectively pulled in the sides.
Can our data shed some light on that idea?
Yeah, where we've got the facing stones, what I want to do is to fit a plane against those stones and try and see whether the face is bulging or dipping in.
Steve wants to fit a flat level plane to the side of the facing stones on the lower section of the pyramid to determine if there was a structural failure in its construction that led to its radical redesign. Steve thinks that if the stones dip in, it means the interior of the pyramid collapsed inwards, forcing the builders to change the angle before they reach the top. However, if the stones bulge out, the pyramid was in good shape when the top section was added, with the bulging being an acceptable consequence of the heavy load pushing outwards over time. The blue planes have been added to our scans around all four sides to show what happened to the pyramid faces.
So let's start by looking at this one. What happens here is the blue is right on the casing stones that are on the outside face of the pyramid.
That's a perfectly flat, level surface.
Yeah, that's a perfect plane that's fitted to the stones. And what we can see here in this center section, these stones are actually pushed out from that plane. So the bent pyramid is bulging on this face in that central section, which sort of starts to give you the theory that it's actually not a failure. It's actually been designed like this. So turn around, let's have a look at another side.
That seems to be exactly the same. What does that say about your original survey?
Well, I think it's wrong.
Remarkably, the laser scan data has convinced Steve that the top of the bent pyramid, so long thought to be a hasty rescue mission, is actually a deliberate feature.
By structural analysis, this was designed like this. It hasn't failed. This is actually a great success.
The scans suggest to Steve that the shape of this pyramid was exactly as the Egyptians intended it. The ancient engineers had successfully built a structure bigger and more grand than anything that had come before. But had this process also been reflected in the most important room of the pyramid, the burial chamber of the pharaoh? Here, Steve finds yet another leap forward in engineering skill. This tall and narrow chamber has a bigger volume than any other burial chamber we've seen, almost 700 cubic meters, and the staggered rocks lead to a lofty 16 meters in height at the very top.
The size of this thing, I mean, it just goes up there more than 100 feet. So this is very impressive by the sense of ambition.
To see the scale of the chamber in unprecedented detail, Steve can again turn to the laser data. It's almost 9 times bigger than the last chamber we saw. This is the most elaborate tomb the Egyptians had engineered so far. Now they had the technology to be able to create even bigger spaces within the body of a pyramid.
So what we learn from this is they'd actually thought about the method of building spaces inside pyramids and a way to create those spaces very large.
Suddenly they've got the engineering know-how to be able to do that.
Our scans have shown us the ambition and scale the pyramid builders had now reached. The vast construction of the bent pyramid is over 1 million cubic meters in size. And crucially, the burial chamber has evolved from the modest tomb that lay deep under the very first pyramid to this gigantic burial chamber inside the body of the pyramid itself.
We've seen the birth of pyramid building and we've seen how it's evolved over time, but to really understand how the Egyptian engineers took that knowledge to the next level, we need to scan this.
Our journey through a century of pyramid building has arrived at the peak of pyramid design, the Great Pyramid of Giza. It's the oldest and only surviving member of the 7 wonders of the ancient world. It has a base spanning 230 meters, and it contains over 2.3 million stones, each one weighing an average of 2.5 tons. It was completed in about 2550 BC by the pharaoh Khufu. In size and technical accomplishment, the Great Pyramid represents another huge leap forward. Here, within less than 100 years of building their first pyramid, the ancient Egyptians achieved building perfection. It's still one of the most mysterious structures on the planet, and we're hoping that our technology can shed new light on this engineering masterpiece.
What do we say that hasn't been said already? What new things can we find out?
Well, luckily we've got new technology, so
Yes.
we can learn new things. We're going to get more data than anybody's gathered before. There isn't an engineer on the planet who wouldn't love to be in my shoes today. It's a real privilege.
Steve wants to use the lasers to uncover something he's always wanted to know. Just how precise is the Great Pyramid's construction? Was precision building the key to its success after earlier pyramid failures? And now, with our cutting-edge analysis tools, we hope to find out.
So scan plan, what is the quality of construction? Levels, lines, sort of overall impression of each block of the pyramid. I want some finer detail on the rocks, the joints, how it's really been put together.
Okay.
Whilst the team gets to work on the task of capturing the Great Pyramid in intricate detail, I've enlisted the expertise of Egyptologist Vasil Dobrev to find out more about why the Great Pyramid is such an iconic structure. Does this pyramid represent the pinnacle, if that's the right word, of pyramid engineering and architecture?
Absolutely, and that's why it's so attractive, because here we have solutions. Khufu adopted new engineering. After him, they'll never do this anymore, because it's so complicated. They never repeat this.
With the scanning progressing well, structural engineer Steve has a unique opportunity to get hands-on with the Great Pyramid, to see how much the design has evolved from the earlier generations. And now, close up, he can see one of the big clues to this engineering feat.
For the first time, they're building really flat surfaces. They've thought about the whole idea of coursing, the idea of building brick walls where you lock them together, much like we do today.
So was the key to the success of the Great Pyramid in its accuracy? Was achieving a level of building perfection what made it possible? In Tech HQ, the data is waiting. Steve has asked the scan team to draw a straight line along a row of blocks. And from this we can see just how accurately the stones have been laid. Running the line at just over 160 meters in length, it only deviates by 3 centimeters from end to end.
Everything you look at is perfection. We can see that there's just no blemishes, the proportions are absolutely right. They had the quality to deliver the very best of the best.
The first thing what I'm really shocked, in brackets, how horizontal it is. And you see it so perfectly.
It's not just good, it's perfect.
They arrived to the perfection.
By rotating the point cloud, Steve and Vasil can look at the pyramid from above, seeing it as the Egyptians intended it to be seen by their sun god Ra.
You see it from point of view of Ra.
I know,
And that's it. That's what. Sure, that's how it will be seen from the sky.
Not only that, we can just see how perfect everything is.
You know, this is the most difficult thing in the construction of the pyramid. How they can join the 4 sides on one point. Imagine.
Yeah.
On 147 meters, they succeeded to put it on one point.
The accuracy of the pyramid's exterior is a marvel of ancient engineering. But what about inside it? Steve needs to venture to the heart of the pyramid to analyse its most important feature, the pharaoh's burial chamber. This should be the pinnacle of Egyptian pyramid building. But how far had the ancient Egyptians come? The evidence is staggering. A gigantic rectangular chamber big enough to fit in a 2-story apartment.
It's wild to think that all that effort and all those millions and millions of tons of rock were for this space, this perfect box that we're standing in.
Yeah, it's remarkable, isn't it?
The chamber is entirely constructed out of red granite, including the remains of the royal sarcophagus, which would have been hugely expensive at the time, the final resting place of the mummified body of the pharaoh Khufu. At one point, the chamber is thought to have contained treasures that the pharaoh planned to take with him to the afterlife. But experts believe this room was robbed of its artifacts long ago in ancient times.
It's quite emotional here, right in the heart of the pyramid. When you think about just how much time has gone by, it really does boggle the mind.
And there's one piece of engineering within this space that is particularly impressive. Unlike the other burial chambers we've scanned, this one has a completely flat roof. A hugely complicated engineering challenge, and a seemingly impossible task with such vast weight at play above it.
Everything the Egyptians learned over 100 years is applied in this building. The whole idea comes to fruition in this location.
Earlier burial chambers saw the roofs angled into points using the method of corbelling. It was a way of spreading the huge weight around the open chamber space, preventing it from being crushed from above. So how did the ancient Egyptians manage to produce the completely flat roof of the mysterious king's chamber? The team wants to scan the burial chamber inside the Great Pyramid to see how its flat roof has withstood the huge forces above for thousands of years. And above the roof of the pharaoh's tomb are smaller spaces that Steve also wants to analyse. This is the first time that these 4,500-year-old chambers have ever been scanned.
What I want you to do is to scan each chamber. So the idea is we can position them exactly above each other and understand how the loads and forces are spread through this pyramid right down to the ground.
The scanning team have to negotiate a nerve-wracking path to get the scans. And Steve is hoping that this data can hold the key to understanding the internal structure of the pyramid. And back in Tech HQ, the hard-won data gives a whole new view on the inside of the Great Pyramid. The results are remarkable. The tomb sits near the center of the pyramid with a vast amount of weight bearing down on top. And although it has a flat roof, it's above it that the structural heavy lifting is being done.
We're looking at the burial chamber. So this is the sarcophagus, this is the entrance. And we're seeing the relieving chambers above.
Rather than angling the roof as in previous tombs, inside the Great Pyramid, the hidden chambers above the tomb are shouldering this vast weight. This allows the ancient Egyptians to engineer a flat roof in the burial chamber for the very first time in pyramid history.
The way they actually transferred this massive load down the outside was basically by corbelling in at each of these levels, finishing at the top with these massive stones that rest on each other. I mean, the forces at the top there must be crushing that rock together.
The relieving chambers form one of the most remarkable structures in architectural history, allowing the Egyptians to engineer a burial chamber larger and further within the pyramid than any tomb structure before.
What they've done is actually create huge stones on the outside of the walls to bring in the edge of the burial chamber and make it much narrower. What I'm seeing here is an engineering principle practiced on smaller pyramids, but delivered here on a huge scale.
Rather than overhanging stones by a few inches, the Egyptians overhung them here by several feet. And in the very top chamber is a roof with a peak where all the weight of the pyramid above is distributed.
This is where the magic happens. This is where hundreds of thousands of tons of pyramid spreads around the burial chamber that's way below me to send those forces down to the ground. They invented this to deliver a perfect burial chamber.
The scans have shown a brand new perspective on the inside of the pyramid. And there is something else within the scans that's captured the attention of our expert, Vasil Dobrev. Historically, experts have pinpointed the burial chamber in various locations in the pyramid. Vasil believes that the burial chamber lies under the western face. Now, with the accuracy of our laser scanning, he is fascinated to discover its exact location.
Let's do this, Malcolm. Let's put a line, vertical line, through the center of the sarcophagus, straight through the top of the Great Pyramid. And if we look from the top, have a look at the plan view.
The chamber is more to the south than to the west. It's not at all where the plans are putting it. They are putting it much here.
For the first time, Vasil is now able to see the precise position of the pharaoh's burial chamber. The scans are showing that the tomb is actually located in the southeast of the pyramid.
So it is much more to the south and to the east. And look at this, interesting. This is exactly on the diagonal. It is the corner.
For Vasil, this is a revelation, but one that makes a lot of sense. Experts had previously suggested that the southeast corners of the three Giza pyramids may have been intentionally aligned to point to the ancient city of Heliopolis, the principal place of worship for the sun god Ra. And with the location of the king's burial chamber now confirmed, Vasil is convinced that the scans have breathed new life into this theory.
They're aligned on the southeast angle, and the line goes to Heliopolis. The chamber is maybe indicating this thing. No, but,
I love the surprise on your face.
yeah, but now I have to search for new things. And what I start to see now is that the southeast angle of the monument becomes interesting.
In the past, the only tools archaeologists have had to locate the chamber within the pyramid was surveying equipment. But now our laser scanners have been able to bring a new level of precision to this ancient structure.
You open a new page.
No, I like it. I love the idea of opening a new page, and it's great that the data, you can see it in a way that you find new things, and I see it in a way that I find new things too.
You open one door, and behind there are 10 others. Well, I have to change some pages of my PhD, you know.
With our scans, we've cast new light on the ancient pyramids. Over the journey, we've discovered how ancient Egyptian building techniques evolved over a century, from the very first multi-story building to the pinnacle of high-rise ambition, revealing how their engineering successes and failures brought them ever closer to the crowning glory of the Great Pyramid, and offering fresh insights that could cause archaeologists to re-evaluate the most studied structures in the ancient world.
To be able to come here and study and compare all the pyramids in such detail is so exciting, not only because it helps us solve mysteries, but because it helps us pose new questions. It helps us turn the page and start a brand new chapter.